Hi. It's always a very dramatic intro video here. It's really good. So, intentional code. What's this really about? What's with the funny title? So you've all had this feeling when you've opened a piece of software and your inner monologue is screaming, why is this like this? Right? You go to edit something, you're peeling away 4 levels of projects or assemblies or JavaScript files, and actually to find where the stuff is that does the work takes you about half an hour, and then the thing you're actually doing is like 3 lines. That's what this talk is about. It's about all of that bullshit, right? That is a waste of time. It's rubbish, and we hate it. So we're going to feel, and we're going to learn how to deal with those feelings and maybe make some stuff better. So my name's David, and I spend way too much time thinking about software design. It's kind of my toxic character trait. I'm the head of software architecture for a company called New Day in London. That's kind of irrelevant because the truth is I'm a programmer, and in reality you will pry my keyboard out of my cold dead hands, and the thing that you kind of feel when you program for a very, very long time is you get this kind of sense of where things got good and where things got bad, and when we have to undo some of the poorer decisions that we've made. So that said, we're not going to look at an awful lot of code in this talk. This is really about design. So I did a bit of a small viral tweet maybe last year sometime, and I was trying to fix up a really, really terrible, awful, horrendous code base, and I was really, really mad at this god-awful thing that I saw here, this horrible design pattern. So I did what I always do when I see something I hate. I opened up Twitter and I rage tweeted into the void. And I remember just sitting there and thinking, this is a damning indictment on what people think design is in software. Twitter obviously mostly agreed with me. But the thing that really jumped out from me at this particularly shitty code base and this horrible, thoughtless organizational pattern is that, there was no thought that had gone into this at all. You know, organizing code by architectural feature is way up there on the list of hate crimes you can do to your code base because there is no meaning, there is no reason why. It's a default answer that feels good but has no purpose. And my inner monologue was just screaming, why is this like this? So I'm going to try and answer that question, because the truth is that organizing your code by architectural feature is like buying 100 classic cars, getting your hammer out, smashing them up and organizing them by wheels and bonnets and windscreens. You lose all sense of what the thing is. It's horrible, it's just parts. So much talk that you'll hear about software design always ends up getting dragged back to all the work done in the 90s, mostly around design patterns. So this isn't a talk about design patterns, but I want to pay them a little bit of lip service and due respect, because I think people often might misinterpret what I'm saying as some kind of tirade against design patterns, and it's really not that. So design patterns originated in the works of Christopher Alexandra, who wrote this wonderful book called Notes on the Synthesis of Form, which is like my progressive metal album title, I think. And he was an actual building architect who was working on writing books about form in actual architecture. And a lot of these books were consumed in the 70s and 80s by people like Kent Beck and Ward Cunningham, who ended up writing a lot of works about pattern languages and software as a result. And then, we end up with this book that I'm sure many people have at least seen photos of before, even if you haven't read it, because it dwindles in relevance now. So the Gang of Four book came out in 1994, and it was probably the foundational text when we think about design patterns that attempted to lay out a series of structural, creational, and behavioral patterns to describe common solutions to common problems in software of the day. Now, that's exactly what they were. They were, here are things that we have seen that work all the time, so we're going to write them down so people remember them. And that's what patterns really are. They give language to concepts. And when you give language to concepts, you can talk about them and you can iterate on them and you can grow them. So that stuff was really awesome, and all this foundational work that was done deserves a lot of respect. But we're not really here to talk about patterns, because what patterns do is they try and make categories of problems look the same. And actually, I want to talk about everything that doesn't look the same in your software, everything that's a little bit different. So I suppose I just kind of lament that most of this talk about design always devolves into patterns, because they're kind of the least interesting part. I really don't care which bits of your software look the same as everybody else's software. I want to know what's special. I want to know what's interesting. So if design patterns are about the familiar, And with the acceptance of that, what we've kind of done in the time since these foundational works is we pushed programming languages to innovate and make some of those patterns obsolete over time. And, it kind of feels like as we made those patterns obsolete, we forgot to talk about things that weren't predictable or common, because that's where real design starts, when patterns and templates end. Now, on the other end of the spectrum, when we talk about design, we end up talking about large-scale architectures. So you'll hear people talk about things like n-tier architectures or hexagonal architectures or 12-factor apps. And they all try to offer prescriptive rules around the form of an application. But I think software design kind of has more axes than just functional patterns and large-scale architectures. And I think that all the most interesting bits of designs are the ones that affect the way a programmer interacts with the system on a minute-to-minute basis, rather than the one time when they're drawing out the plans at the start or in the middle. So why this is really interesting to me, and like on a deeply feely personal level, is back in the depths of time I was an art student. And I literally studied literature and fine art and painting in the 90s in high school. I studied politics for my sins, but I always wanted to be a programmer, right? Because programming was interesting. It was magic. Like, making stuff is awesome. I love it. Kind of call back to the name of the conference. So at the very, very start of my career, I really struggled to reconcile this kind of aesthetic sensibility of art and design that I'd been grown up learning with these kind of design pattern books that were seen as the most authoritative works in software development at the time. And I really couldn't see where kind of aesthetic sensibility and real design was being talked about in these things that were just recording common answers to problems. And then, I went and I did a computer science degree after studying art. And during the first year of my comp sci degree, like a lot of people, I stumbled into Donald Knuth and the Art of Computer Programming, which I didn't read because no one's ever read it. But what I did read was another book that he wrote about literate programming. And he wrote this book way back in 1984, which was literally the year I was born, so there's clearly no new ideas in the world, really. And what Knuth had done is he tried to get traction around this idea that software should be written by combining a documentation language and a programming language. And those two things together produce comprehensible code bases. And, it's pretty philosophical, I suppose, and it's very consistent with the rest of Donald Knuth's work. Because, this is the man that took 10 years out of writing his famously unfinished series of books so he could write the text editor to write his books in. So very, very consistent that he was thinking hard. And the interesting thing that struck me reading this book on literate programming was that the programming languages that I was learning with in the early 2000s now were a lot more literate than the languages that he was describing in the 70s and 80s. And actually, so many characteristics of our programming languages that we use today are closer to natural language. Actually, he was kind of right. It just ended up being in a space of language convergence rather than this concept of like a documentation language and a programming language as two separate pieces. But this core idea really resonated with me, that software really is the same as literature, and you can treat it like literature. And this was kind of a little bit of a revelation to like baby programmer David, and it changed the way I started writing code completely. Because software only becomes good software and when it's written like literature, and literature is only good literature when it's written for the reader. Light bulb moment. Okay, cool. Let's design with that in mind. So, over the years, I've come to this conclusion of what I think software really is. And, I believe that software is a constrained form of communication between programmer and programmer that describes concepts and problems that also just so happens to be executable. The fact that we can run it is almost a side effect. What we're really doing is we're describing answers to problems. And the more you think about that, the more it starts to make sense. You spend a much larger part of your time reading code than you do writing it. Your code exists in a context, it has subtext, it has authorial intent. Sometimes when there are bugs, you're the unreliable narrator that didn't quite get your point across. And the code itself that you write has form, it has flow, just like any other writing. And most importantly, the code has meaning and it has intent. So intent was the thing that stuck with me. And, here's the funny thing. lots and lots of people talk about this book when we talk about what good code looks like. And I mean, I don't want to be the book burning guy, but I would maybe suggest you burn your copies of that book. And the reason I would suggest you burn your copies of that book is what it's done is it's taken all notions of quality and design and reduced them down to boring, yak-shaving debates about language naming at best, right? There's nothing in here about actual design. It's a really dogmatic book, and I think it's actually muddied the waters in conversations about design rather than making them any clearer. I think it has its place, and I think maybe 15 years ago it was a book when there were no better books in the space, but I think it's kind of been replaced by now, and we shouldn't really be talking about it. Everyone is like, oh, that's heresy. You can't say that about clean code. I like writing clean code. I'm a software craftsman. Hear me out. There was a point in my career, too, where I thought that basic rules about hygiene were enough. But, you know, since then I've come to value actually the intent of what I'm doing over rules and hygiene and naming. And what that means to me is that every character matters in the work that we write because the software is fundamentally the work. So I want you to think about your code like every character matters. The white space matters, the rhythm of your code matters, the naming matters, the form matters, and the function matters, all equally. Code written with thoughtfulness and intentionality are what matter. Now, we're going to go through some examples later, don't worry, there will be some code. But thinking of your software as literature lets you value different ways of communicating in code. You know, we can communicate on the macro scale with organizational patterns and application architecture. So the classic example of this is like an MVC app. So MVC, everyone will have seen that before, is an organizational pattern. And what it does is it dictates the way in which you split up your code and all of its common implementations. It kind of tells you how to organize your stuff. But I kind of have this love-hate relationship with MVC because as an organizational pattern, it's excellent. You know what to expect. But when you want to understand the intent of a piece of software, all the MVC pattern does is completely obscure the intent of your code because all you see when you open that code base is an MVC app. It has models, views, and controllers. Excellent. What does it do? Who knows? Go intentfully read every single bit before you can understand it. So it's a good example of an organizational pattern that tells you how an app works while obscuring intent. Now, I actually find the micro-scale design more interesting, where the form of your code on a function-to-function level in a module-to-module way kind of telegraphs intent. So what we do is we use form and flow to increase cohesion. So let's take a look at an example of how that works. So if we're to use form and flow and cohesion on a micro scale, we're going to look at two screenshots here. Now, you don't really need to understand what this does, right? So this is a pretty ugly function that does some HTTP-related things. And it's kind of difficult to read because there is no form and there is no flow in these lines of code. So what you're doing is you're forcing your brain to compute and build up state of every single statement individually in your head. Now, we used paragraphs in text in written language to group related concepts before moving on to something else. Code is exactly the same. Now, lines mean something. They carry intent. And if you use them everywhere or nowhere, you remove an entire category of expression from your code. And now this is like a really small scale example, and it does a great injustice to the effects that code with great form and rhythm kind of have on a code base. What we're doing here is we're showing what's related. It's kind of an aesthetic sensibility that reflects how the flow of control in the software is designed to be interpreted. And all we did was group some lines together, right? So what you're doing is when the reader reads it, they read, and they pause, and they read, and they pause. And the effect on a maintainer is completely different. So form is intent. It's important. That's what design is. And the more I started thinking about software through this kind of lens of literature and intent, it became apparent to me what I was really reacting to was the inherent complexity in a lot of modern software. You know, what I was doing is I was really craving clearer communication and well-written prose. And that was really this grander design problem, right? So I've been working on a sentence recently. Spoilers on the screen. I'd never thought I'd say the sentence, I've been working on a sentence. And this is how I feel about complexity after 25 years of programming. The complexity of your application should be at most as complex as the problem space it inhibits and no greater. And I started thinking about this a lot, and really macro and micro design are the tools we have to contain complexity. And like so many systems, straight out fail this test. That system that you opened when you had to peel through 30 layers of abstraction to get to the 3 lines of code that did something, fail this test. Too much complexity, not enough value. And that kind of design buries systems. It makes working in those kinds of applications feel like swimming through treacle. And it's like that we forgot how to build small things that are exactly the correct size for the problem space we are inhabiting. And I think it's a shame, because the code that I think is really beautiful is actually the code that overperforms on this index. Things that somehow contain an enormous problem space with a really, really narrow, tiny, tight implementation. Now, the interesting thing about thinking of software in these terms of design is that even the use of the word design is a little bit contentious, right? And design means a lot of things, and it's easy to mistake it for other things like it. Now, design exists to communicate intent and solve problems. That's why design isn't art. Art is what we do to deal with the human condition. Design is something that we use to communicate a meaning that everyone can understand, 2 very separate things. But design is also temporal in nature. And many designs only make sense in their context, and even where great design is timeless. So especially when you look at our software, we look at these 2 things here. Now, these are kind of great examples of what I'm going to jokingly now call period design. Now you all feel old. There's this really interesting observation that these 2 iconic designs, as an example, weren't actually the last of their lines either. They actually evolved and changed over time, because design is fundamentally an iterative process, and it changes based on the context that you are in. Phones didn't cease to exist. Walkmans didn't actually vanish. They were both iterated out and converged. Because the irony, of course, was we realized that the problem was transmitting audio, not listening to music or making phone calls. And one better design could solve both of those problems. And in fact, when you think about design like that, there's something really beautiful about how symmetrical it is with the inherent iterative process of software and the things that are completely born of software. So you take a process like TDD, and obviously TDD has a little bit of a background in like the scientific method of testing assumptions and moving quickly. But actually TDD is beautiful because it's something that's fundamentally of software. And there's this rising trend of people who will complain about TDD who I can tell you have never done it. And the reason they've never done it is they get like the red-green bit and they make the test pass. And they never iterate, and they never improve, and they never change the software. And that's the same thing that good design does. It iterates over time. And the same thing good software design does using tools like TDD is iterate out and change. And the thing that's really beautiful about that as a discipline is that there are some categories of things that you just can't understand until you see them, right? And I think processes like TDD really highlight that. And I think it's really interesting because lots and lots of programmers don't perceive themselves to be very, very visual people. There's a lot of like, we're sciencey people. But actually, everything is visual that you see with your eyes by definition. And, I think that we look at something like TDD and its incremental process where we evolve the form of something, and you can see the same work that people did in classic design of physical objects and signs and iconography writ large in our software. It's beautiful. So, as an aside, I think once we look at this framing device and we look at software design as actual design, it's worth us realizing that the context that our modern software in also has changed since a lot of our design patterns and these foundational works were written. We're not building generally desktop software anymore. We're not burning software onto CDs that we can't change after the fact. And a lot of the ways that we interact with our software changes because of those constraints changing. So I'll tell you what makes all the kind of 10th generation clean architecture folks really upset about this talk with, most of the things that people tell you are best practice are just overblown structural design patterns. That's basically all they are. And best practice more or less just means here's something I saw work once, which is cool, and that's fine. Things are allowed to work once. But I see a lot of system designs these days that have been fragmented, especially in like a post-microservice world, right? Where these kind of trends towards best practice have led to people atomizing and exploding systems into hundreds of moving parts. And actually, those big designs start to bury what the system does. You lose it in all of the infrastructure and build pipelines and automation and God knows what. And the problem is that when you look at it from like 30,000 feet, it looks fine. Oh, you've made responsible decisions and split your things up. But actually, it's nonsense on a low-level detail basis. So I want to show you an example of this happening in a real application that I was helping a team with recently. So don't worry that you can't read that. You're not meant to be able to. So this is a class diagram that I generated from a system that was built following like a prescriptive, clean architectural pattern. But all I see here are telltale signs of thoughtlessness. So this system, which was in the process of being recomposed back into a single application, was divided into a huge number of modules, all of which were subdivided by architectural feature. So the whole thing is an API with like 13 projects, and each one of those had a business logic layer and a data access layer and a common library tying them all together. I mean, you've seen designs like this everywhere, right? This is incredibly common as a pattern. But all of that stuff was coupled together at the bottom with some shared components, and the total cognitive load of understanding all of those moving parts is just correspondingly huge at that point. And, some would describe it as well-intentioned and well-designed. The irony to me was all this stuff was maintained by one team of 5 people. So the bigger irony is the actual code looked like the thing on the left there, and actually when we finished with it, we'd shrunken all the implementations down to the thing on the right. They'd basically totally neglected the quality of the actual implementations in favor of making sure all the big boxes were in the right places. Classic case of people focusing on macro design over quality. So how did we spot and fix this, and what was the impact? Well, we did a first round trim of the complexity, and we collapsed all the families of modules, and we rolled them up into each of the corresponding top-level web applications. So all those business logic and data access libraries were just 13 web apps side by side. And then, rather than the application depending on those lower-level modules, we then deployed them all using their existing build pipelines, and then we looked at the build pipelines, and what we discovered was all 13 of those applications were being deployed onto the same server. So what we actually had was one repository with 64 assemblies and 64 build pipelines times by 3 environments to build a web app. So we just copied and pasted all the files back into a web app and shipped it. And the funny thing is, the reason the team came to me for help was their builds were taking 17 minutes. And the reason the builds were taking 17 minutes was because they were running into I/O limits, copying files around. It's a perfect example of how design really can both crush productivity and your end result. So yeah, the builds after we finished all this took like 20 seconds, 24 seconds, solved the problem. So after the work was completed, we got 64 modules and 19 build pipelines times 3 environments into one application that looked like that. That was the whole design. And then over time, the team could use their tooling to fix up the low-level rot, and that's what made it important. We've got to remember to build smaller things. Now, there are, of course, certain problem spaces where there are well-known good structural design patterns. And the most obvious glaring example is like RPC-style systems like HTTP APIs. They often quite neatly map to kind of command query handler patterns. And in those systems where you're using known good structural organizational patterns, the form and the flow of your implementation matter all the more, because what you really want is you want things that are different to look different. That's the way you want to lead the eye. So I suppose what I'm reaching for here is, it's not just what you say, it's how you say it that's important. And it's funny, it always reminds me of this story that I heard about about filming the 3rd Star Wars movie. So George Lucas was historically a terrible scriptwriter. This is like a known thing. And his wife at the time was an editor, which is why the later ones sucked and the earlier ones were good, because they got divorced between the two. And apparently Harrison Ford stormed off stage after doing like 30 retakes in a row of one line because the script was so bad in the third film. And he screamed at George Lucas, like, George, you can write this shit, but you can't say it. And so many things in software feel like that to me, like not the right way. So one of the core problems when we talk about known reference designs is that it's easy to learn a single design pattern or two and decide that everything in your software is that thing. This kind of over-pattern matching, because as programmers, what we do is we pattern match for a living. That's kind of our mental model. And I promise you, you do this because I have made all of these mistakes in my career myself. Maybe you will recognize some of these. I learned about MVC and I thought everything was a controller. I first learned about aspect-oriented programming and I thought everything was a chain of interceptors. When I was told that controllers should only ever do HTTP stuff, I thought everything was an application service. When microservice design first got popular, I thought everything had to be completely decomposed into microservices. I have made all of these mistakes. It's okay, this is how we learn. I think the truth is it takes some time to kind of learn that uniformity is the opposite of expressiveness. And it's important that when different parts of your software do something different, that their form reflects their function and they don't look the same as everything else in your code base. You know, we need the visual variation. We need to be able to read. So I guess what I'm trying to say is I think intentionality is the opposite of complexity. You know, stop doing things just because. Stop cargo culting design decisions because you saw it worked well one time. If you don't understand why you're doing something, stop doing it. So, you know, the truth is if you can't justify to yourself a choice, you shouldn't. Now, unfortunately, because so much of software is context sensitive, there are many times when blindly applying patterns makes software so much more difficult to reason about, but at the same time, makes you feel good, because there's nothing better than knowing you've got like a known good, correct answer to something. It feels good. But our real job is fighting this complexity. So when I talk about complexity, I want to dig into this term because I'm often surprised that lots of people have very different definitions of what complex means in software. So I've been reading this book recently, excuse me, and there's this great quote from the book, A Philosophy of Software Design by John K. Oosterhout. I'll leave some links to it at the end of the talk. I think it gets to the heart of why complexity is a problem in software. So what he says is that complexity isn't caused by a single catastrophic error. It's tiny paper cuts that accumulate over time from the collection of dependencies, obscurities, and idiosyncrasies at work. Complexity isn't your design being bad. It's all of the small things that add up. So Oosterhout describes complexity as the thing that leads to what he describes as change amplification. So the more complexity, the harder it is to make changes until you can't actually make changes. It leads to high cognitive load and an increase in unknown unknowns that leads then subsequently to an explosion of work. And ultimately, you can measure that by the number of modifications you have to make to a code base to enact a single change. Now, building on that definition, I think intentional, thoughtful design is this salve for this creeping wave of complexity. And there's a distressing realization that you get to when you come to this line of thinking, which is just that design patterns are so popular because it gives people an answer that they feel like is good. It's an answer that they've reached a definite conclusion. And once you go through enough code bases and enough languages, what you realize is that most of the arbitrary stylistic qualities that people often focus on, things like tabs versus spaces, brace style, all that garbage, is just totally irrelevant. Instead, there are a couple of kind of non-negotiable qualities you look for in code. So, you know, I kind of feel like good code is code that's easy for someone with minimal context to consume. It's code that focuses on developer experience and debuggability and usability. It's code where the intent takes more of the visual space than the language, where you're not looking at syntactic constructs, you're looking at the what your software is doing. And regardless of kind of language or style or intent, that's because all programmers interact with software in the same way. You skim read, and then you deep dive, and you read quickly, and then you read intently. And good code, regardless of style, makes that process easy for humans. And you know, at a meta level, all code is constructed from like a from abstractions and encapsulation, right? These are very, very common terms. And regardless of programming language, this has always been the case. And I think programming languages and runtimes and frameworks hide a lot of this stuff from you. You know, languages often have, well, languages are based on frameworks with their APIs, which encapsulate operating system APIs, which encapsulate hardware APIs, and there's like a huge stack of complexity that you interact with on a daily basis. But the cool thing about it is, if all of those things are written well, you never really realize that all that stuff is going on. And, you know, a good encapsulation, a good abstraction reduces cognitive load because you don't worry about it. And I want to talk about the really, really obvious example here. You never really think about what happens when you do file open in any programming language. But file open is like a terrifying API with spinning disks and file systems and God knows what else underneath it. So Oosterhout actually uses this example in his book. You know, he says, if you think of a module in a piece of software, this could be like a package or a class or an assembly. Its interface represents the complexity that the module imposes on the program that consumes it, right? So things with big interfaces and lots of options mean that the potential complexity is very, very broad. The smaller and the simpler the interface, conversely, the less complexity consuming that thing imposes on the program. So the best abstractions are really, really neat, narrow ones. And you knew this, right? You know this when you build things. But the reason that they're good is because precisely the amount of things that your code base is exposed to as a result of consuming a narrow abstraction is very, very limited. So file open is beautiful. And Oosterhout describes it as a very, very deep module because it contains the entirety of a problem space with a very, very narrow interface at the top. And I think, you know, it's useful to look to that when you're designing your own modules for inspiration of what makes things good. Now, as much a factor of kind of avoiding the wrong abstractions is also finding the right ones. And this may seem like painfully obvious advice, but abstractions, and generally any other module of code that you find, should contain a problem space in its entirety. So what does that really mean? Well, it means that abstractions that have things like pass-through methods are bad, right? And often you feel this when you're wading through layers of software that seem to do nothing, but the reason they're bad is they completely reflect the complexity of the module underneath to the module above, right? And that's the impetus you need to tear all that stuff, all those pass-through functions, all the wrapping classes that you have out of your code bases because they have precisely no value. And in fact, they amplify the complexity you're exposed to. Now, our software is kind of riddled with these thoughtless abstractions, and really what they are is just poor encapsulation. And every time a design decision like that is made, it decreases the reason that that module exists. Anything that adds a lot of boilerplate basically is bad design, and that is the reason why. So I also want to kind of advocate for an end of absolutism in design a little bit, because you get to a certain part where you talk about design a lot and you learn one absolute truth. I can tell you that if anyone thinks they have come up with the one perfect design that solves all of software, they are categorically wrong. Right? That's the only truth about design and software, that there is no one design that solves all your problems, right? Because any design, when stretched to its logical, absolute extreme, becomes absurd. So designing software with intention and software that survives is kind of this exercise in compromise and articulating the constraints around your design. Because really, design is what happens when you satisfy the constraints that you have, not just when you apply a pattern that you have learned in the past. You know, and in fact, I think a lot of the poor trade-offs I see in software involve people actively not understanding the sources of complexity and weird design in their software itself. Doing things like taking additional dependencies, so packages or services, for like simple, narrow use cases. So there's a lot to be said about maintaining like 30 lines of code rather than like a whole dependency that you might have to manage and version. Because dependencies are part of the total surface area of your software, and the features of those amplify complexity. Now, it's interesting because this is kind of an uneasy bedfellow, because conventional wisdom normally says, oh, don't write things yourself if you can get them for free, right? Oh, there's a package for that. Why don't we use that thing? But actually, as an example here, I recently wrote a 200-line static site generator. And I wrote a 200-line static site generator to make a 30-page website, because I looked at all the ones on the internet and everything was marked as experimental, and I sat there and I sighed. And I was like, if I use any one of these, this is going to break in 3 months, and I'm going to have to fix it. I'm going to have to fix it in another 3 months after that. Whereas writing 200 lines of code that I was never going to change, absolutely less complex than adopting something that I didn't own. I think all your designs should be expressions of those kinds of trade-offs, right? They should be choices. And they should be compromises, and there should be a gentle balance rather than like a single idea or layout or correct concept dragged to its extreme. So, in fact, once you start kind of considering things in design as a trade-off, what you realize is that instead of rules around system design, what you end up with is tests. And I don't mean coded tests, I mean tests which you use to evaluate the qualities of a design of the system that you're building. So I want to take you through a few tests that I use with some of the teams that I work with. So I often ask people if they could do the thing they're doing with less moving parts. And this is very, very contrary to a lot of kind of microservice, nanoservice, distributed monolith orthodoxy. Because generally what people don't realize is that the more moving parts you have in things, you just increase the likelihood of failure every single time, right? And actually taking things out is often better, is often simpler. So there are many places in our ecosystem where people kind of balloon complexity just by splitting things out just because, without understanding that the true cost of ownership of pulling out a dependency involves build pipelines and repositories and code owners and pull requests. Like, there's no such thing as just separating a thing out without actually having to answer all of those questions. So use less things. Is this operable in a production environment? Software and systems that are hard to observe or don't contain instrumentation, that are difficult to deploy, are slow to upgrade, are not backwards compatible, are bad designs. Because I can tell you what, the only certainty in life with your software is that you're going to have to change it. So if this stuff is not easy, then actually your design is bad. And finally, is it easy to change? Because, it's important to avoid that kind of over-design at the start. Because, one of the classic problems that people fall into is they try and imagine every category of change that they could make and build a big design that is never exercised. And we've all seen these systems, and it's very, very kind of common knowledge that we shouldn't be doing this, but I see it time and time again. And actually, you should invest time in just making sure that change is easy rather than that your design is comprehensive. So I guess what I'm really kind of advocating for here when I plead for intentionality is for you to write your software with care. I want you to think about the design of your software. I want you to think about the reader. I want you to think about what flow and form do to your application and what it tells the person that is consuming it. I want you to use all the forms of expression available to you in a code base to communicate meaning and intent. People often overlint their code bases, for instance, which takes away an entire category of expression. Different problem spaces and different solutions require different aesthetic viewpoints. And we should embrace that, lest we damn ourselves to either the only two designs you ever see being a load of HTTP calls in an MVC app or a React component, because that's basically what everything will boil down to if you don't think more carefully about it. And it doesn't have to be that way, right? Because I think that the really lovely thing is that when I see code bases where people have taken time to craft APIs that are beautiful, their care shows. And like, if I was to go back to kind of that art student perspective, like, I kind of look at the work we do, and this is probably very feely of me, but like, if I was still painting, I would have a body of work that were paintings. And actually, I kind of look at the software I write as my body of work. It's the thing that I will leave behind that is my expression of a skill that I have trying to do something important with it. And I think that means something to me. And I know that, maybe it's a little bit passé to be like, oh, really care about the code. So in some ways, it's often just a job. But it doesn't mean that you can't be proud of the work, right? And I think that's super important. So I was on a podcast a couple of years back, and I was asked that classic shithead question at the end of the thing where they're like, oh, we got one for you. But what advice would you give to yourself 25 years ago? And the wonderful thing is, in the process of writing this talk, I think I know the answer now to that question, which is just take more time. And, I reflect on the way that I work myself when I'm programming. And all of the best work that I've ever done has involved me sitting at the end and putting some music on and pouring a drink and spending a couple of hours just reading the software. And I read it like a critical reader would read it. And it's kind of, I don't know, my own personal form of introverted code review. And I read through it and I ask myself, why did I make that choice? Why did I use that language? Why is that structured like that? Why did I put that there? Can I justify the choices that I've made? And spending that 20% extra time really giving care to the software that I've written has resulted in designs and pieces of software that I am both truly proud of, and people have come to me and been like, this thing is beautiful that you've written. And in the times that has happened, I've always been like, oh, I'm so glad you've noticed, because God, I just lost 5 hours of my life staring at those 4 lines. I'm glad you love it. And, I think that's a really powerful thing that's, a bit silly, but, it makes me never stop asking why, right? Always take more time, never stop asking why. I think those are the 2 biggest pieces of design advice that anyone could ever have. So I want to leave you with a few reading recommendations after this, because these books are brilliant, whereas the other one isn't. So these are all relatively modern. So there's A Philosophy of Software Design by John Oosterhout. There's Your Code as a Crime Scene by Adam Thornhill, which is really, really cool. And there's a book called Code That Fits in Your Head by Mark Seaman. Actually, since I did this slide deck, Kent Beck put out a new book a couple of weeks ago called Tidy First, which is a dictionary and a catalog of really, really well-applied kind of micro design patterns. And the way he escapes the design pattern trap is he just calls them tidying. And I think that's really nice, really, really super nice. So yeah, buy the books, support the authors in our community. Thank you very much.